When scientists talk about beauty in a physical theory, they mean that it can describe a whole range of diverse phenomena with hopefully simple concepts and simple maths. Take Einstein's theory of general relativity, our theory of gravitation. You can write it down in one line. Now, the trouble with the Standard Model is, well, it takes pages to write down, but also there are elements in it that are mysterious, arbitrary even.
There's something spooky about this Standard Model. It doesn't really work. So we know that there's something sick in our theory.
For example, we have at the moment what we call a standard model of particle physics. Works great. Only one small problem. If you write down the equations of this model, it would seem to suggest that no particles would have any mass. But clearly that's not true.
For all its power, the Standard Model overlooked one of the most basic, fundamental properties of our world. It was incomplete in its description of the universe. What's missing is an explanation, a mechanism for how the fundamental particles acquire mass. Now, we know intuitively that the things in the world around us have mass. We can feel it. It's what makes stuff stuff. But what is mass and why does it exist? Sounds simple, but it's become one of the most difficult and challenging problems in physics. There must have been a time in the early universe when the particles became substantial and took on their mass. The best theory we have to explain how this happened was dreamt up one day by a British physicist, Peter Higgs, whilst walking in the Scottish Highlands. He came up with a theoretical mechanism that could explain how some, but not all, particles attain mass. The Higgs mechanism works by filling the universe with a field, the Higgs field. And by the universe, I don't just mean up there amongst the stars, I mean here, in front of me and inside of me. And particles acquire mass by interacting with the Higgs field, by talking to it. The theory is that every particle in the universe is traversing this invisible Higgs field. And some particles, like the quarks and electrons, acquire mass as they pass through. Whereas massless particles, particles like photons, don't interact with the Higgs field and they just pass through the universe at the speed of light.
The Higgs brings simplicity and beauty to a nature which looks too complicated. It introduces a kind of symmetry and a kind of beauty to nature which gives us an understanding of one of the most puzzling features of this little model I told you about, the Standard Model.
The Higgs field may solve the problem of missing mass in the Standard Model. But the only trouble is, we haven't been able to detect it yet. But there is hope, because it's a law of quantum physics that all fields must have an associated particle.
Now, it's a key prediction of this Higgs theory that there should be a quantum of this field, a particle associated with it, and that's what's called the Higgs boson.
is there a Higgs particle? And if there is, how does it appear? How does it come about to simplify our view of the world? It would be a tremendous discovery.
If we can find this new fundamental particle, the Higgs boson, then we'll be one step closer to understanding how the universe came to be the way it is. No wonder Lederman called it the God particle. The Higgs mechanism is our best attempt to repair the Standard Model. But over 40 years after it was first thought of, the Higgs particle, the one thing that could prove the theory correct, hasn't been found. So the only way to prove the theory correct is to try and create the Higgs boson for an instant inside a particle collider. Some thought that Fermilab with its powerful Tevatron collider would have found it.
Fermilab is working day and night and day, with a machine that's ever increasing the number of collisions. But I would say probabilistically, we won't find it. Ever since the Higgs particle was dreamt up, and despite billions of dollars worth of research, Fermilab has not seen even a hint that the God particle exists.